Okay, in this video, we're going to summarize all the acylation reactions that we've come across so far. They all occur through the nucleophilic addition elimination mechanism. Okay, so we are going to on the top and the things in green here. These are the things that are going to be acylated, and they've so we've got our alcohol. And of course the first step in the mechanism is going to be that is going to go and attack that carbon there. Okay, so that and we've got our this is our primary amine. Again, the first step in the mechanism would that be to go and attack that delta positive carbon there. So very similar. What we haven't talked about before is like we've got water there. And water, if you like, is like a special kind of alcohol, in which case it's got 0 carbon atoms. So instead of having an R group there, it's just got an H. But it's, that is going to react in a very similar way. Look, that's just going to go and attack, let's go to the acyl chloride, that's going to go there. Okay, and the mechanism is going to be the same. Okay, and the same, well, if we consider water to be a special alcohol with 0 carbon atoms, we can consider ammonia to be a special amine with 0 carbon atoms as well, and that's going to react in a very similar way. Okay, so the very first one we did is we had a carboxylic acid reacting with an alcohol, and the product we're going to get will be like this. Okay, now there's 2 R groups, don't have to be the same, they can be different, of course. And that is an ester, isn't it? That's an ester we formed there. And what is the little molecule that is eliminated there? Well, it's going to be that H and that OH, so we're going to get water. So it's going to be H2O. Let's do now what would happen if the alcohol reacts with this time with the acid anhydride. Well, what's going to happen is right, this bit's going to drop off, isn't it? And it's going to join up with that H there. So the little molecule we're going to get is going to be a carboxylic acid. But let's do this first. We're going to get an ester. So we're going to get the same product we did with the carboxylic acid, same organic product. It's just that the little molecule that's eliminated is different. It's going to be the carboxylic acid. Okay, so I'm doing the little molecule in red every time. Let's finally do water with the acyl chloride. Well, we're going to get the little molecule we're going to get, right, you're going to lose your Cl and your H there, so you're going to get HCl eliminated. And here, we're going to get the green, we're going to get an ester. And we are going to get the small molecule is going to be HCl. Okay, so let's now do what would happen if water react with a well, I won't do carboxylic acid first, but let's do what's happened with the acid anhydride. Okay, so we're going to get that drops off, and just like this time we had that H joining it. Well, it's not. There's going to be that H there, let's say, and so let's get rid of that. So the little molecule we're going to get is going to be a carboxylic acid. And what is the product going to be? Well, the product is going to be this, the organic product. And we're going to stick that onto there, aren't we? Okay, so what we're going to get, we are going to get a carboxylic acid. So we get a carboxylic acid as the product, as the organic product. And the small molecule which is eliminated is also a carboxylic acid. Let's do what happens with the acyl chloride then. So we're going to lose that, aren't we? Okay, so let's see what happens there. So the organic molecule is going to be, and the green from the water. Okay, so we're going to get a carboxylic acid again there. And the small molecule which is eliminated is going to be HCl. Now that's why I left this one last. Well, what happens when water reacts with the carboxylic acid? You're going to get that H is going to react with that OH there. So you're going to get water as a little molecule, and you're going to get you're going to get a carboxylic acid forming. So there's the blue, which comes from the carboxylic acid, and here is the OH from the water, the green. Okay, so you're going to get again the organic molecules, your carboxylic acid, and the small molecule eliminated is also carboxylic acid. Sorry, it's not carboxylic acid; it's water, isn't it? Okay, so you can see in this particular case, then it looks like no reaction has occurred. You've just swapped the OHs, and that does happen. When you have a carboxylic acid dissolved in water, you could show if you use radioisotopes. If you made this oxygen 18, you could show that some of the oxygens in the water end up in the carboxylic acid. There's a constant exchange going on there. Okay, but you wouldn't notice anything happening. So you can see a few patterns beginning to emerge here. We can see as you go down one of these groups, as you go down, you can see the organic product is always the same: carboxylic acid, carboxylic acid, carboxylic acid. And on this one, it's going to be ester, ester, ester. Right. Okay. And as you go across that way, what happens there? You get a different organic product, but what's the same is the small molecule which is eliminated is always the same. It's always H2O in that top row, carboxylic acid in that next one, HCl in the next one there. So there's some method to it. Yeah. Okay, so let's do the carboxylic acid with the primary amine, and you're going to get right. So you're going to lose that H and that OH. The small molecule is going to be H2O. And you're going to get an N-substituted amide. And there's the R group from the amine in green. Now, that reaction wouldn't actually work very well, would it? If you react a carboxylic acid with an amine, you get a tiny bit of reaction, but you'd get a very poor yield. And if you wanted to make it, you would never use the carboxylic acid because the carboxylic acid is not reactive enough. You would have to, of course, go and use the acid anhydride or the acyl chloride if you wanted to get a decent yield, but it's just for the sake of showing the patterns here. We left that there. Okay, and the small molecule which is eliminated is going to be H2O. We can tell that because as we're going across here, look, the small molecule is always the same, isn't it? It's always going to be H2O in that row. Let's do the next one down. Okay, so as we go down, it's the organic is always the same, isn't it? So we're going to get the acyl, we're going to get the N-substituted amide again. But this time, right, what's the small molecule we're going to get? Well, we're going to lose that bit from there and that from there. So we're going to get a carboxylic acid as the small molecule, which is eliminated. I should write down that N subs amide. Same here, N substituted amide. And when it reacts with the acyl chloride, we're going to get the N-substituted amide, aren't we? And the small molecule which is eliminated, well, it's going to be that H and the Cl there. So we're going to get HCl, which we knew because we're going across in that bottom On the bottom row, as you go across, it's always HCl as a small molecule, which is eliminated, and that's the N-substituted amide. Okay. N-subs amide. Now let's see what's going to happen with this last one with ammonia, which we haven't actually looked at this, but we're going to be able to predict what's going to happen there quite easily, aren't we? So we're going to lose, let's see, we're going to lose that H there and that OH there. So we're going to make water. So we are going to get, let's draw the organic molecule. And again, it would be a very, very poor yield this, but just for the sake of completion. So we're going to there, and we're going to get, now, what is that? It's not an N-substituted amide, it's just an amide, isn't it? Whenever you have a carbonyl next to an NH2 group, that's what an amide is. So we get an amide there, and the small molecule eliminated is water. With the acyl chloride, well, the small molecule eliminated is going to be carboxylic acid, and we're going to make an amide again. So let's draw that down. As the small molecule is going to be the carboxylic acid, doing red every time, and this is going to be an amide, is the name of the organic product. Finally, with the acyl chloride, well, we're going to lose the H and the Cl, so that's what's eliminated. So we get HCl as a small molecule, and we're going to get the amide again. So this coming from the acyl chloride, this coming from the ammonia, and we are going to get HCl as a small molecule and the amide as the organic molecule. Okay, let's just think which. So we've completed that, but just let's think what's going to be the fastest one. Well, the speed of reaction is going to increase as you go down there, and you're going to get a better yield. The acyl chloride is the best, isn't it? What's the disadvantage of doing it with an acyl chloride? Is you make this HCl every time, which is corrosive. So if you use metal pipes in an industrial process, it's going to corrode them. So you might not want to use that. You might want to use instead the acid anhydride here, because then you only make a carboxylic acid, which isn't going to corrode. It's an acid, but it's not going to corrode metal pipe work. Okay. Right. Also, another advantage of using the acid anhydride is it's cheaper than the acyl chloride. Okay, so that's the end of that video.